We're going to continue our discussion on elimination, and you can see in this system of equations right here that none of the variables match up. There are no terms that are going to end up eliminating each other on this one. So I've got to adjust things like we did in our last video. However, there's not a nice number to multiply 6 by to turn it into a 9. I'll end up with some decimals or some fractions. And same with turning a 2 into a 13, I end up with decimals or fractions. And I don't really want to use those right now. I can avoid them using the method that we'll see today. So we're going to go way back to our days of finding least common multiples. They end up being very convenient for us to keep us from having to use decimals. The least common multiple between 9 and 6 is 36. So if I chose, I could turn both of these into a 36. The least common multiple between 2 and 13 is 26. So if I chose, I could turn both of these into a 26. I'm not going to do both of them at the same time. I'm going to pick one. So let's work with our y variables. We're going to turn both of these into a 26. I can do that by multiplying 2 by 13 and multiplying 13 by 2. Both of these will then be 26. I need a negative in order to get them to eliminate when I add them together. And so I'm going to choose one of these to turn into a negative 26. Let's do that with this lower one right here. So this will give me a positive 26y, this will give me a negative 26y, and then we'll be ready for our elimination. Okay, you notice that I didn't write any of the other stuff down immediately because my entire decision is based only on what's happening here. Whatever else happens with all these other numbers, I'm going to let happen. I just need to turn these into 26 and negative 26 so they match up. However, I do need to remember that if I multiply this by 13, I need to multiply all of these also by 13. So now that my decision is made, I can finish this out. We're going to multiply this by negative 2 and multiply this by negative 2. That will create a new system of equations that we can work with. Now, we're going to end up with some bigger numbers here. I don't really care because if I can't do it in my head, I can do it on a calculator. So 9 times 13 is 117. That was easy. Once I've made my decision, then I know exactly what to put in. 2y times 13 ends up getting positive 26y. And then 39 times 13, 39 times 13 is 507. Over here we have 6x times negative 2, which is negative 12x. We have 13y times negative 2, which is negative 26y. And I'm going to pause for a second. You'll notice that we now have terms that eliminate each other. They're set up, ready to go. On the right-hand side, we have negative 9 times negative 2, which is positive 18. All right, let's add these together. 117x plus a negative 12x gives me positive 105x. These two add together to become 0, so they have eliminated. And over here, 507 plus 18 gives me 525. So our new equation is 105x equals 525. Let's divide that by 105, and we get x equals 5. Awesome. Big numbers, no big deal. We can plug them into the calculator. However, now that I have this, I'm going to go back to where we had our smaller numbers and put it back in here so that I don't have to deal with these 500s and all sorts of stuff. So our x equals 5. I'm going to put that in here into this equation. So we get 6. My x value we now know is 5 plus 13y equals negative 9. 6 times 5 is 30. And we'll eliminate that by subtracting 30. We get 13y equals negative 39. And we can divide by 13 to get y equals negative 3. We now have both of our values, so let's write them as an ordered pair. That gives us 5 and negative 3, and we're finished. Thank you.